everyone, we're going to discuss this curve with respect to concavity, points of inflection, local max and minimum, and then use this information to sketch the curve. So to do this, what we're going to do is take the first derivative and the second derivative and get that out of the way. So let's just call this, change this to f of x. So we're going to do f prime of x equals 4x cubed minus 12x squared. And we can factor out the 4x squared. We get x minus 3. And we're going to eventually set that to 0. Let's go ahead and take the second derivative while we're here. It's an easy polynomial derivative. 12x squared minus 24x. And factor out the 12x. And that's going to give you x minus 2. So we'll be using that in a minute. Now, what we're going to do first is find the critical numbers. We need to know if, when we set this to 0, what are our critical numbers? So our critical numbers are x equals 0 and x equals 3. And then to evaluate these, we're going to find our maximum and minimum. So all you do is you look at your second derivative and plug them in. So basically when you plug in 0, so f double prime, let me do this in a different color, f double prime of 0 gives you 0. Well, that doesn't tell you anything. So this one is not enough information. So we don't know what's going on at this. It gives us no information about the critical number. Let's try 3. We plug in 3, we get negative 27. Since it's negative, means that's a local, since it's negative, it's a local maximum. So remember, you're going, when you have negative, that means you're going, the negative should be on this side of the curve. So this is positive to negative. All right. So now that we have that, we need to still figure out what's going on with this, because we have this 0 here. So we're going to test for inflection point to see if it's an inflection point. Now, what we're going to do is set this to 0, the second derivative, to do that. And you're going to get x is 0 and x is 2. So I'm going to go to the second one and second slide and do a little sine diagram. We have 0 to 2. And let's look at, we want to look at when x is less than 0, when x is in between 0 and 2, and when x is greater than 2. And I'm going to do the intervals as negative infinity to 0. That's this one. And then I'm going to do 0 to 2. And then we're going to do 2 to infinity. And that would be this one. And we're plugging it in this number, 12x times x minus 2. I'll just put that there. F double prime of x is 12x times x minus 2. And we're going to check for concavity to see if we can get the inflection point. So, if we plug in a negative number into this, this is going to be negative and negative. So 2 negatives are going to be a positive. So that means concave upward. All right, 0 to 2, so let's plug in 1. If I plug in 1, I get positive and a negative. Positive times a negative is negative. So that's concave downward. All right. And then let's plug in 3. If I plug in 3, I get positive, positive. So that's going to be positive. That's going to be upward. So basically, since it's switching from upward to downward and downward to upward, or positive to negative and negative to positive, that means we have two inflection points. The point 0, 0 that we had from the previous slide is an inflection point since it changes from concave upward to downward. Also at 2, that's an inflection point because it's changing from downward to upward. So if I write 2 and plug in 2 into this equation here, I'm going to get, that's going to be 2 comma negative 16. So these are your inflection points. I'm going to call it IP. And then you had your, also your maximum, your minimum value was at 3 comma negative 27. So let's look at the graph. A little extra room. So here and here are your inflection points. Remember when they say sketch the graph, doesn't have to be perfect, so don't laugh at my graph. This is your minimum value we found at 3. This was with the first derivative test. And this one was with your second derivative test. So basically, with our test, we are drawing this curve downward. So this is, no, the concave's going up. So you see how it swings up? And then here at 0, 0, it switches to concave down. Then at 2, negative 16, it stops and it starts concaving up. And then here we're changing the gradient from negative to positive, which we saw with the first derivative test, and it's going up. In these cases, the gradients are both negative, or all three of these are negative. But you do have the inflection points because it switched from our second derivative test. It's switched. And that's it. Thank you. Have a nice day. Bye-bye.